Let's continue solving max exam. Math B 2012 question 2. Okay, so he's telling you take a point P. The point P is in x equals a and y equals uh, e to the minus a. Okay, with a being bigger than minus 1, and this point is on this curve over here. Okay, it is on this curve, so it makes part of this curve. And let S of A be the area of the triangle surrounded by the tangent line to C at point P. So what does he want? What does he mean with this part? So let's imagine that the curve S of A was like this, okay? So you have tangent line passing through it. In each point a tangent line. Look, in this point this is a tangent line. In this point this is a tangent line. In this point over here this would be a tangent line, okay? So the tangent line passing through that, the point P will make an intersection with the y-axis and the x-axis, and he wants this area. Okay, this is what he's telling you. So let's imagine like this is the curve, S of A. Okay, so and this is the point P over here. So this is the line that is tangent, and this is the area that he's talking about. So this is the idea of the question. Now let's go to the math to solve it. So to solve this question, first to find the tangent line. Well, if it's a line, it's we have that y minus y of a point is equal to m, the linear coefficient, multiplied by x minus x0. Remember this from your analytic geometry. Remember from analytic geometry, this is the formula of the line. In Brazil we call it Yu Mishosho. I like this name. So why is this important? What we are going to, the y, the epsilon, we have it. The y0, a y of the point is e to the a, right? He gave you the y of the point over here. Okay, now is equal to m, we don't know it yet, multiplied by x minus x of a point, which is a. He gave us this. Okay, the idea now is to find the value of m. Remember, if we find the value of m, we have everything in this line. Okay, it's the only thing that we are missing is the value of m. If we find it, we can find where it intersects the y-axis and the x-axis, and by that we can find the area. Okay, so I need you to know why I am trying to find what I am trying to find. Okay, so how do we find the m? Okay, now we are going to use calculus because this is a calculus question, I believe so. So you need to remember that the derivative of a function is the tangent line. Okay, and then we can put this point in the derivative function, and we can find the derivative in the tangent line in that point. What do I mean by this? Okay, so our line is what? Our line is y equals e to the minus x. The derivative of this is y comma is equal to minus e to the minus x, right? This is our derivative, okay, of this function. Really simple. Okay, the derivative, this minus comes from here, and this is the derivative. So if you have any like max is might be strange for some people because it has calculus, so you need to study these formulas. Okay, so now this is the formula for all the tangent lines to this curve S of A. Okay, let's say it is this. So if we want the tangent line to the point P, we just need to plug in the point P over here and we can find this tangent line. Okay, what do I mean by this? Well, the m of the tangent line is equal to minus e to the minus x, but x we are going to plug in a. Okay, why? Because we want it in that point. Okay, and this is the linear coefficient of this is m. What is this m? Remember, I'm taking time with this part because it's important. This is the curve. What we found over here, over here was what? Was the derivative of our curve. So it was in terms of x, so it told us the linear coefficient of every line that is tangent to this curve. Okay, by plugging in the point P, we found the specific linear coefficient for this point. So this is what I did. Okay, this was simply what I did. So now that we have m equals minus e to the minus a, we can use it. Okay, so remember what we had: y minus a, no, sorry, minus e to the minus a is equal to m. What was it? M minus e to the minus a. Minus e to the minus a multiplied by x minus a. Remember? So now we need to find y is equal to so this is our y-axis. This is our function for the line that is tangent in that point for this curve. Okay, this is our line. So why is this important? So because it tells us everything. What do I mean by this? Let's go to a new page. So look, our y was equal to minus e to the minus a, right? The minus ax, and then plus, and let's separate the terms, minus a of a plus 1. Okay, I didn't do anything magical over here. Okay, so what I did basically was, we had this was our goal. Okay, this was our goal. We found m, and then I separated to find the y, the epsilon. Okay, alone. So now you need to notice that this is a, a line, because we have only x. Okay, we have these other strange terms, but we have only x, so it doesn't matter how strange it gets. This is a line, and not just this, the line, the a of the line, y is equal to a x plus b. Remember, this part a is negative, so the line is decreasing, right? What do I mean by this? Well, we have our y-axis and our x-axis, so the line is like this, and the question is asking us, remember our goal, to find this area over here. So this is a triangle, this is the base and this is the h, right? So if you could find p multiplied by h divided by 2, we can end this question. If you want to try to end it in this part, This part is no longer calculus, okay? So how can we find the point of h? Well, the linear coefficient of the linear function, right? So this part over here tells you where we are cutting the y-axis. So this point over here is going to be, sorry, this point over here is going to be the point 0 and e to the minus a of a plus 1. Okay, and what about this point over here? Well, this point is where the y is equal to 0, right? So I'm going to take all this and equal it to 0 to find where this point is. Okay, so uh, let's say this is equal to 0. Okay, this whole thing equal to 0. How will it be? Well, we will have that x equals to a plus 1, right? This part goes to the other side of the 0 and this part goes dividing. So if you do this algebra part, you'll find this. But what x is this? It is this x over here. This is its value. So now we have the base and the h. We have everything about our function, right? To find the area of our triangle. So what can we do? Well, a plus 1 multiplied by h. What was h? E to the minus a multiplied by a plus 1 divided by 2. This is our s of n. So s of n is equal to e to the minus a of a plus 1 squared divided by 2. So this is our s of n. Now let's save this result over here. This will be important. This is the answer for 1.1, and for 1.2 he's asking you, I don't have it over here because the question was big, but he's asking you find a such as s of n will be maximum. So how do we do this? How do we go on solving this? So the idea of this would be, now we have s of n, right? We have s of n. So if we derive s of n and equal it to 0, we find the maximum point. This is the one of the first thing you use to when you are studying calculus, right? Derivative. We derive, find the first derivative equal to 0 to find the maximum point. So this is what we are going to do. Okay, so let's derive s of n. So the derivative, no, s of n is equal to e to the minus a of a plus 1 squared divided by 2. So s of n comma is equal to what? Now the part of 2 is a constant, so we will only be dividing by 2 after it. Okay, so let's do this. This is the derivative of a product, right? So the first derivative minus e to the minus a, repeat the second one, a plus 1 squared, plus repeat the first one, the derivative of a product. If you don't know what I'm doing, look it up when you're studying calculus. Okay, and now the derivative of the second point, so we will have 2 multiplied by a plus 1. Okay, this is an a, and divided by 2. Okay, so s comma of n would be equal to, now look, we have e to the minus a and e to the minus a. I'll take it outside. Okay, so e to the minus a is equal to, now 2 multiplied by a multiplied by 1 is equal to 2a plus 2, this part over here. Now let's do this part over here. Okay, now minus, remember the minus sign, minus a plus 1 squared, a squared plus 2a plus 1, all this divided by 2, okay? So let's go to another page. So our s of n comma would be e to the minus a of 1 minus a squared divided by 2. Now this part over here we can do better with it, okay? So we can say that s of n comma is equal to e to the minus a of 1 minus a multiplied by 1 plus a divided by 2. Now if we make this equals 0, we find the s of n maximum, right? When s of n is going to be maximum, the a of s of n maximum. So notice, for it to be 0, either this part is 0 or this part is 0. So either a is equal to 1 or a is equal to minus 1. This cannot be. This one cannot be. Why? Because in the question he's telling you that a is bigger than minus 1. So the a we are choosing is a is equal to 1, okay? Over here he's telling you this. 1 second. Over here, a is bigger than minus 1, so we need to choose the other one. So over here, so in our function, in the normal s of n, before we derive it, we had that it was equal to minus e to the a multiplied by a plus 1 squared divided by 2, right? So now when we have it, that a is equal to 1, we'll have that e to the minus 1 multiplied by 1 plus 1 squared divided by 2. 1 plus 1 squared is 4, divided by 2 is 2, so s of 1 is going to be 2 divided by e. And this is